All righty, everyone. Well, first off, I want to welcome you all, and I'm going to upload a couple of items into the chat here. And the first one is a mechanical COMcheck. So if you feel like following along, it's not the same one that you'll see on the screen, but you'll be able to see a lot of the similar aspects of it. I also uploaded the handout for the class so that you can follow along. All right. I hope you guys are ready because it's going to be a fun-filled morning for us all. Let's talk about COMcheck, the mechanical COMcheck, and the heating and cooling load calculation. So just remember that, we all have jumping off points, right? And when we talk about the energy code, right, when we look in the code book, there's lighting provisions, there's mechanical provisions, there's thermal envelope, there's plumbing requirements. And that's because we all have an effect on various things. Now, very importantly, our thermal envelope is going to have a big effect on our mechanical items, such as how large of a piece of equipment do we need to have? And then how do we ensure that whatever piece of equipment that you are doing will actually meet the criteria of the efficiency and the sizes and all of that. And that's where these reports actually are quite beneficial. So let's go ahead and take a look at the mechanical COMcheck. And I'll throw it in the chat again. I'm going to try to stay organized here. But this report, as you can see on the right-hand side here, there's a lot of items in there that we're going to walk through. The first thing is our HVAC systems. What exactly are we going to utilize? And then what is part of these systems? Meaning, what type of fuel source, right? What size of it? Does it have these other features part of it? Our fan systems. Now, you'll hear me, kind of preach about it, but this is one of those sections of the energy code that is probably the most under utilized and maybe one that is least understood about what it's talking about. And I'll admit, I don't know all the ins and outs of everything that's in there, but I also know of a great tool that helps me with it. It also has things when you go into the software itself, it's the plants. They call them plants. And that's dealing with like boilers, cooling towers, things of that nature that it falls under because it's not quite under one category, but it falls under another category. And then one that is probably often missed is the water heating component. So whatever your service water heating system is, it's actually required to be placed and put into the mechanical COMcheck for it. And the nice thing is because the energy code has like efficiency requirements, the COMcheck looks at it and says, oh yeah, that works, right? Hey, Ken. All right, so let's dive into what the mechanical systems are. So what we're going to look at right now is if I am a designer and I choose to go on to COMcheck and enter information into the mechanical component of it, this is the screen that I'm going to see. And in this screen, right now we're under the HVAC systems, and you can see it tells us, okay, so HVAC system 1 contains a heating and cooling component of it. It tells us what type it is. So our heating is a central furnace. Our cooling is a single package DX unit. That means obviously, it has heating and cooling to it. It gives us what our capacity is for each piece of equipment and the fuel type. It also tells us what type of condenser is it. It's air-cooled condenser. And then it includes things like our fan system. So here's our fan system listed in here, and we'll talk about that in a minute. And then very specific details for our design of the system, right? It's a single zone. For cooling, it also has an air economizer, right? So you can say, hey, I'm having an economizer, it's an air economizer, or it's a water side economizer. It's kind of really dependent, but you get, and what you're proposing, your efficiencies for that equipment is going to be. And then in this particular one, it also contains information for a PTAC, because let's face it, you're doing hotels, and even now with, I'm seeing some multifamily that are utilizing PTAC systems. So just, be aware, we got PTAC going on, and that's something that we would find here. Now, what this system ultimately, everything that you see here on this screen in COMcheck ultimately is going to produce a report, and you have the report there available for you that I've uploaded into the chat here. And this obviously is not the full report, but it's blocking out some of the things. So what you'll see here, again, your equipment type, fuel source, capacity, proposed efficiency, required efficiency, and the economizer, everything that was listed up here, we've got the information put in here. So this is where I want to really break down the report so that you have a really good understanding of what everything is trying to tell us here. So right here, it lets us know the quantity of this system, because let's face it, especially when we're talking commercial, sometimes we don't have where it is a single system that's getting utilized, right? Sometimes we have multiple ones that's dealing with a building. So if you have 5 of this specific type of system, then our quantity here really should list 5. Now you could have one that is that's like this, and then one that instead of, having 60,000 BTUs, it's 80,000 BTUs. So then you're going to have a second one, and then maybe there's one of a different efficiency. So you could have, I've seen mechanical COMchecks that could have up to, like 14 different system types that are put in there, but all of them should be on there. And I've had ones that it's just a single type of system, but they have 15. And so this quantity should be listing the number of equipment systems that are shown on the plan. So I will take this and compare it to the equipment schedule on the plans and ensure that the number that I see here in this COMcheck matches the numbers that I see in the equipment's schedule there. Now, to break it down even further, when we're talking about the heating appliance, this is how we're able to ensure that what we see here actually matches what we have on the plans. Because let's face it, we're all human. I've had COMchecks provided that were for a different project, and it's just a matter of I inadvertently, printed up or sent over or uploaded, right, the wrong one. And, like I said, we're all human. So this is a good way of ensuring that we have the correct one. So our heating, our type of appliance, this is the central furnace, right? Then it also lets us know what our fuel source is. It's gas. So if you don't see any gas lines being ran, I would question it, right? Now, typically, this should list what the capacity is. I have this one on here just so that you can see that there are times that it could potentially be shown as an unknown, but if we look at the one, whoops, if we look at the one here in the same location, this one is telling us that it's 50,000. So I just wanted to show the two examples on here to make sure that you have that in there. And part of that is where it might say unknown is there are certain aspects of when you're in the software that if you don't, I forgot what they call it, but kind of, assign it to the piece of equipment, it might be listed. So it could just be operational error where they forgot to assign the capacity to the piece of equipment. And then
Question for you, Hope.
oh, yes.
So looking at this, we have that unknown right there. What about the unknown on the HVAC? So where it says quantity one, HVAC unknown, would that
What
be what was responsible for that?
No, actually, what that is because when you go into the software, you kind of get to name the equipment. And so there's a button in there, and we could potentially go into COMcheck and see if it actually will show up. I was just in there and it wasn't working, so I don't want to promise that it's going to work. So if we come here, we'll log in. So let's go to our New Mexico office. If we come here to mechanical, there we go. And we want to go into our HVAC systems. You'll notice that it says the component, oops, I was trying to, this here is, the system up here. But if we wanted to go in and add an HVAC system, so we're going to say that we're going to name it. So it's going to be a XYZ, right? And it's a central furnace, right? And then we're going to say here, I'm just picking things. So now it talks about the name. Oh, we're just totally spelled wrong. Okay. And we're going to say 40, next. Okay. So now we have this and it shows, I forgot to put unknown, but if we go and of course I'm trying to do this very quickly. So sometimes
Didn't mean to throw you off.
No, it's fine. It's fine. It's good to show this. So we're just gonna, and we'll see if it actually works. Yeah. Yeah, it's not gonna pull up. I'd have to go in there and plane it. But basically,
Yeah.
if you don't label it, it pulls up as unknown. I was trying
Okay.
to show the correlation with that. So my apologies, everyone. I didn't have it prepped. I should have had it prepped. But getting back to the report, this is the important one. So here it is saying, here's our proposed efficiency of what we want to install. And then this is telling me what the required efficiency is. Now, I get this question a lot. How do I know that this is correct? And because sometimes this one happens to be the same efficiency metric for it, but especially when we get to cooling and even some of the other ones, heat pumps, they have different metrics, right? You have SEER and then you have IEER, which do two different things, but sometimes the efficiencies will be a little bit different and it's hard to know which one, if it's correct or not. And the really great thing is if it is not correct in COMcheck, there is nice red lettering that pops up that states, hey, this equipment unknown, does not meet the required efficiency. So this actually helps you in kind of not necessarily having to go through the, 16 tables to try to figure out which one is the correct table and does this piece of equipment fall under this category or this category. It kind of does the work for you. I like to use the mantra work smarter, not harder. And mechanical COMcheck is you'll see here. You'll be like, after this class, you'll be like, yeah, hope I get it. I love this thing too. All right, so let's look at the cooling. So now we have a well, that cooling is going to the wrong part, but it should say single package DX. Oh, there we go. It moved now. The capacity, unfortunately, here it's shown again unknown, but it would be like 40,000 BTUs or 40 kBTUs. It gives us what our proposed efficiency, it gives us what our required efficiency is. Now, the one thing that I will say is missing in this particular report, and honestly, I've had to call this out on numerous occasions, is the economizer information. We should see the economizer information shown over on the right-hand side. That's usually where it is located. And it should tell us a few things, you know, what type of economizer is getting utilized or what exception it's going to have, you know, or utilize for it. So this is not in any of the reports you see. This is a separate one. So it right here, you'll notice that it says air economizer. So now we know what economizer is getting utilized. It's an air economizer. You can also see a water site economizer. It's really kind of dependent on the type of system that's going in as to what economizer is appropriate for it. And plus, the other thing I wanted to show you is, you notice on this one, it says unknown, right? You'll notice this one says RTU3, and then it tells us that it's a single zone. So back in the software, that's where that comes from. Now, in this particular instance here, this one tells us we have an air-cooled condenser. Now, the really great thing is, if we look at this PTAC one, it also says, here's the economizer, but it says no economizer, economizer exemption, and then it tells me which one they utilize for that exception, and which is really important, which is wonderful if you think about it, because it lets us know, hey, you know, this is what we have, this is what they're doing, and they qualify, right? So it's a wonderful, wonderful tool. So I just wanted to show you, here's one that is calling out an air economizer. And then here is one that is talking about the exception, or the air-cooled condenser. And then here's the one utilizing the exception. Now, the one thing I did want to kind of bring to everybody's attention is the single package DX. And what the DX is referring to is that the furnace and air conditioner are in that same unit. And so I just want to make sure that, like, that acronym is well understood here. All right. Let's jump into the fan section. This happens to be that part of the code that, like I mentioned, is often misunderstood. I would say, you know, like utilizing Hope's philosophy, because that's how Steve Thomas taught me, of doing plan reviews, of where you go page by page by page by page, right? Section by section, because most of it doesn't apply to a project. But everybody gets to this fan section, and I'll admit, when you read it, it's incredibly confusing. When you read it, it almost feels like there's some double talk in it, for lack of a better word. We'll go into this a little bit deeper, you know, in Clovis, but COMcheck is really here to kind of take all of that murky water and make it a little less murky for all of us, so that we can kind of see it's clearing up and we can almost see the bottom of that puddle. So the fan system, So in this COMcheck, you'll see it right here, right? We've got fans. Now, what this information gives us is it lets us know what option they chose, because remember, there's two options that they can pick for a fan system. Now, this only applies to a project if the fan or the single fan or multiple fans in a system equate to 5 horsepower or more. If it's less than that, it doesn't, this section doesn't apply to it, which is sometimes why you might not see any fan information. It just doesn't have the capacity that it's, warranted. I will say for the most part, most commercial projects probably get to the point of where a fan system is probably going to be implemented. So it lets us know which option they utilize. It also tells us whether it passes or doesn't pass. It gives us the information that we need as far as, how much the CFM that's going to be utilized. It also gives us the efficiency of that fan, because guess what? If we're going to have a fan running in a system, which we have no problem with, right? The energy code's like, yes, please use a fan system. The only thing we ask is that fan be energy efficient, which is basically what we are looking at on this. So now we're going to break down what this is telling us. So this first line here for the fan system of XYZ, you can see I like utilizing XYZ a lot because that's just easy for me, I guess. XYZ. And then it says, we are going to utilize the motor nameplate horsepower option and fan efficiency method. Now, there is another one that can be the brake power horsepower option. That one's a little bit more complex than this one. The motor nameplate, I'd say, is probably used 9 times out of 10. But it is an option. So dealer's choice, right? It's not something that we as code officials would choose. It's the choice of the designer as to which way they want to gain compliance with it. Now, right here, it lets us know that the whole system, as it was entered into COMcheck, passes. Now, obviously, some of this you would have to verify on the plans, but this is saying that it passes. Now, the next thing, I'm going to get my laser point, I just realized, is now we need to know what is the CFM of this particular system. So in this system, it's called 12 supply, right? It's a single zone, and it has a VAV, which is a variable air volume system. So that triggers something a little bit different, but it's okay. In Clovis, we'll get into what that VAV represents for us. But then it tells us that this system is 150 CFM. The next part right here lets me know that it's a 5 motor nameplate horsepower. So it hits that 5 mark. That's why this is triggered. The next section right here tells me, okay, I have to have the energy efficiency index of what that fan is going to be. And in this instance, it's telling me that it's 15. For a, if it was a fan, it has to have 1. And if it happens to be a VAV, I believe the VAV is 95% or 0.95 efficiency for it. So this obviously well exceeds it. Now, it does call out here, fan exception, a single fan that happens to be less than 1 horsepower or less than 0.89 kilowatts could be utilized in this system. So that is an exception. That's an example of the fans. Now, what I want to show you here is here's an example of a fan system that happened to fail. And as you can see, It says system compliance fails. The proposed efficiency fails to meet code requirements. So this is incredibly important. This lets me know that this fan system doesn't work. So it's another clue for me as a plans examiner, me as a designer. I need to, if I'm a designer, I need to go in there and tweak it because maybe one, I didn't attach something or assign something, I mean, or, I just have maybe the wrong efficiencies in there, right? And so this is a great tool. Like I said, it also, as a plans examiner, I can see this and say, ooh, I need to kick this back to you because you don't have the correct, or write a review comment. You don't have, in this particular instance, the efficiency doesn't meet it. So, all right.
So what would we do, Hope, if that accidentally made it out to the field? As an inspector, we get out there, we're taking a look and see that. My first thoughts would be, hey, we need to take this back to plan review and design, get a correction on this.
I would say, I think how I would treat it as an inspector, and I will say that I've seen this and I've had to treat it as an inspector, is my first stop is, and I will admit this was back in paper days. And what had happened is the plans examiner, I won't say who the plans examiner was, inadvertently had attached to the plans the original submittal of the COMcheck. And so when I went back into the office, the corrected one, or the correct one, was in our office version. So that would be my first step. If by some chance, because we are all human, right? If by chance it had gone out into the field as such, I probably would say, hey, where are we at on this? I would start asking the question, okay, do we have a fan system that qualifies? Because it might have been something in the effect of the fan system doesn't actually qualify, but it was inadvertently, and everybody decided, well, we'll just leave it as is and not have to write up a new report. But if it actually was something that should have fallen into this, then we need to start having those types of conversations. But the first thing I would do as an inspector, which is what I did previously, is I said, I'm going to look at everything, but what I am going to do is you will neither pass nor fail. I need to do some more research on what we have here, but I would have the conversation with the super. I would have a conversation with whoever was installing the mechanical, right? So that everybody was aware this is a situation that we're in, so that, I don't ever want to stop progress, right? But we also don't want to have, systems installed that aren't exactly code compliant either. So it is a fun, what do I want to say, line, right, that we have to follow with all of that. All right, let's take a look at what our plants, our HVAC plants, right? So this is talking about things like if you were installing a boiler system as opposed to forced air systems, you're going to get that information in there. So with this, you would have your equipment type, right? So this happens to be a hot water boiler. It's 100,000 BTUs an hour. That's your capacity. It also gives you what you're proposing your efficiency is going to be. It's an 85% AFUE. And then the required efficiency is 84% AFUE. Now, one of the things you'll notice on the mechanical COMcheck is it doesn't have a pass fail by so much percentage, right? It just has the information there. There's no green bar. And what you do get is it's basically like, here's some supplemental documentation, not necessarily a pass fail, because it's not where everything is dependent on one thing. One little component could fail, like your economizer isn't correct, so that could pop up, or your efficiencies, or your fan systems fail, right? So it doesn't have that green bar. So I just want to make sure that everybody is aware of that, because while this efficiency is above it, you don't get the percentage of a correction for it, right? You're not trading between it as you do with some of the other ones. So, all right, let's talk about our water heaters here, right? This is always the last one in there. So whatever your service water heating is, it should give you information about the type of equipment, right? This one is a gas storage water heater. So we know that it's gas. It also gives us our capacity. It lets us know too, do we have a circulation pump involved with it, which is incredibly important, because if we have those public labs, remember that you basically get 6 inches from your water heating source to the fixture, right? And so because of that's why you see a lot of the systems in there that are utilizing circulation pumps, because that plumbing where the takeoff is to go to the fixture, that system is considered, the entire plumbing or the piping system there is considered to be your heating source. So the 6 inches that you gets to come off of that line there, basically. So knowing that you have a circulation pump included in that is important, and it gives us that information there. It also lets us know the efficiencies. Now, for the 21 and what the state has adopted with it, there's no real, not every piece of water heating equipment has efficiency requirements. So it's kind of nice, because the good thing is COMcheck lets us know, okay, this one you don't have to worry about. Or if you look at the table, it's all done by the equations. And the wonderful thing is COMcheck does the equations for you and lets you know when there is an efficiency requirement that it does actually meet that. All right. This, like I said, here's all the information that it gives us. Here's our fuel source. Here's our capacity. Here's our input rating. And here's our efficiency requirements. So this was a kind of a quick overview of how to read a mechanical COMcheck. Does anybody have any questions before we move to the fun and exciting heating and cooling load calculations? All right. Well, I'm going to go ahead and move to our heating and cooling load calculations. So this is fun, right? This again is probably one of those that it looks more cumbersome than you might think. And I'm going to give you the, whoops, in the chat, I'm going to put the link to the technical documents. We have a technical document that walks you through the commercial heating and cooling load calculation reports that you get. So you can walk through this or just have it on hand as a resource, a tool, right? So C403.1.1 tells us we have to have heating and cooling load calculations. The mechanical code also has it. So basically our heating and cooling load calculations, the requirement comes out of 2 different code books. That's how important this is. And where it comes into play for the energy side of it is this is where we are ensuring that we are sizing our mechanical equipment appropriately to what the heating and cooling loads are for that building, right? We don't want it oversized and we don't want it undersized. We kind of really, we want it to be, what do they call it? The Goldilocks of sizing, where it's just right. All right, so this is the section that governs it. We're not going to go into all of the fun stuff. What we are going to do is we're going to kind of walk through what some of these reports are going to look like. I will say that this is obviously not every single one of them. There's about 2 software that are utilized often in providing our heating and cooling load calculations. You have Train Trace, which is this is the example that you see on the screen. And if you go to the website and download it, we have an example of Train Trace. We also have an example of Carrier HAP. And I would say that these are probably the 2 most common utilized software that I get these reports for. Now, I do want to let you know that there's a lot of things that fall into this, right? As far as what goes into creating a the heating and cooling load calculations, your elevation, your heating and cooling degree days, how much glazing you use, because remember, glazing and roofing has a big impact on what your heating and cooling loads are. So the amount of glazing you have, the direction it's facing, the type of glazing that you have, and really importantly, the solar heat gain coefficient of that glazing and the overhangs. Remember, the solar heat gain coefficient is the amount of solar radiation heat that is passing through the window or the glazing as opposed to being reflected away. The overhang.
So, question, Hope.
Oh, yeah.
I'm sorry. So on types of glazing, is that safety glazing or is that like skylights and monitors and windows and doors?
It's actually all of that, right?
Okay.
So when it talks about the type of glazing, part of it is, yeah, windows, doors, skylights, but it also takes into account what type of glazing are you using? Is it, you know, a fixed, an operable? Is it single pane, double pane? Very similar to the type of information that gets inputted for a manual J. This is
Oh,
the
okay.
commercial version of a manual J.
Thank you.
No, absolutely. I'm glad you brought it up, Troy. This is why you're here. Thinking outside of what Hope is thinking. And then overhangs. I bring up overhangs because I will say that this is probably one of those sections that may not be thought of, but if you think about it, 100 years ago, you go down south and, you know, while air conditioning has been around for a really long time, it wasn't a common place to have an air conditioner in your home. How you kept your home cool in the summertime is you had these enormous overhang wraparound decks, right? And so the overhang shaded all of your glazing, because let's face it, we did not have good glazing 100 years ago. So overhangs, insulation values, roofing material, the number of lights, kind of lights, occupant loads. The lights had a big effect, right? Even 10 years ago, the lighting industry kind of took hold of the energy code. And so the lights don't produce as much heat as they used to, because the technology's gotten better. But these are all components that play into how a manual heating and cooling load calculations are performed. All right, so now let's take a look at, you know, where we would find some of this information. So in this one, this is telling us where the zone happens to be. So you might have one that'll be for like the entire building. And then they have ones that will be like, here's this zone for this piece of equipment. This is the zone that this piece of equipment will address. And here are the loads that are associated with it. So in this particular instance, This zone was the reception market zone. Now, a lot of the values are going to be the same, whether it's an individual zone or for the entire building. If there is a difference, that's something to call out. But taking a look at it, we see the information here for our cooling, and it says at the peak time, it's 7:14. And what that means is that July at 2 o'clock is your peak time of trying to cool the structure. So it holds that information. Now, the other thing it gives us is the OADB, WB, and HR. And what those stand for is the outside air dry bulb. And in this instance, it's telling us it's 94, right? We have it here, our outdoor air dry bulb. And then it has our wet bulb of 65, which is shown right here. And then it has our design relative humidity, which is 62 here. Now, the one thing I do want to do is jump back to that outdoor air dry bulb temperature. And that number really should be whatever your adopted temperatures are for the jurisdiction that you're working in, whatever the summer outdoor design temperatures are. Now, if we go and we look at what the heating portion is, the heating here is telling us that the outdoor air dry bulb temperature is 8. So this 8, again, should be what your adopted winter outdoor design temperature is. So if you're a plans examiner, you're going to see what you've adopted. If you're designing it, you just need to design it to whatever the jurisdiction has actually adopted for these particular temperature numbers. And that's the information, and we want to, that was here. I don't know why I have that out there. It's out of order. But when we are looking at this, the things that I'm going to look at is what is that outdoor dry bulb temperature number right here? And what do I have for my cooling? So here is my cooling. My cooling says 94. My heating says 8. If those are the numbers that we have adopted, I'm pretty good at that. That's the big one that I want to ensure. Now, the other thing that we have to keep in mind, just like when it comes to our manual J's, right, is the fact that we need to know what went into it, right? And our thermal envelope has, as I showed you, a significant role into it. But here is the report. When I look at for my glass solar, it says 5,237. Do you know what that those numbers that went into it for what the U factor, solar heat gain coefficient factor is, and the type of window that this is actually pertaining to? If you do, I'm going to say hats off to you, because that I have looked at these for, we're getting close to 2 decades, and I still can't look at that and tell you what it is. But what I do is, depending on the report, there actually is an addition to the report. A lot of times you have to ask for it. But once they know that you're looking at it and that you need it, they'll just automatically submit it because it gets printed up. It's just part of the report. And what it is there's a section that will say, hey, Windows, it's this design, and it has this U factor, this solar heat gain coefficient, this visible transmittance, it has this shading, it has this overhang. It'll have all the information in there that equates to what these numbers are in the report. And that's all that I look at. Now, I've also had where they say, I can't get this to print up. So my other option that I have accepted for this, so that I know what envelope values were actually put in, so I could verify that whatever was put into this report is actually the design of the thermal envelope, right? Because there's such a strong connection here. We want to ensure that the thermal envelope is correct, and that what we have in there pertains to, so that we don't have equipment that's oversized and we don't have equipment that's undersized. And to do that, sometimes what I have accepted is I require that the engineer who put this together on company letterhead say for this and the name, the address of the project. And that at that point, they tell me, okay, for the roof, we put in A, for windows, we put in B, right? And then they have to sign it and stamp it. And so I've had people say, well, I don't know if I would trust that. Well, let's think about this, right? If they're willing to put it on their letterhead, sign and stamp it, that's their livelihood that's put on the line there. They're willing to do that, to say, hey, this is what I know I put in there, and I'm going to back it up with my stamp. So I never have a problem with that. Just this is the world according to Hope, right? There we go. All right. So here are a few other things that you might want to consider is you look at some of the loads here, the people, we want to ensure that there's light loads that are putting in there. We have people loads that are put in there, and to make sure that we have that information. We also want to come down here and take a look at what our gross area that's involved with this reception market zone, right? So it's telling me that my floor area is 4,057, and then it says my wall has a gross area of 919, and more importantly, it has 150 square feet of glass, which in turn tells me that that wall is 16% glass, which is another great tool for you, because remember, the code does have a limitation about how much glazing can be installed in a building, depending on which compliance path you utilize. So it is something to be incredibly aware of, and it's just making sure that things match up. Now,
One more question. On our internal loads under miscellaneous, if we had like a dishwasher or a uh, refrigerator, would that go into there? Kind of like it does in the manual J?
it does have miscellaneous loads. Now, remember that this is done to ASHRAE 183. So that information would pull from there. But if I remember correctly, it would be some equipment loads, right? If it happened to be like it's a commercial kitchen, maybe you do have a, cooktop, and that's going to produce some heat. So that would probably be listed under the miscellaneous. Again, you're going to go into standard 183, and it'll show the things that would be placed into that category, and in theory, what they would, the numbers that would be quantified through that. But that's typically where you're going to find something of that nature there. It's going to be something that requires, or something that's going to be part of the system that's going to increase the amount of heating or cooling that's going to happen with the project. And this one, it's just normal. It's just a normal everyday building. There's nothing that's increasing it or decreasing it. And then engineer checks, what I look in here, I do a couple of things, but I do a little bit more on it. But the big thing is I'm going to look to see how many people is it talking about. And part of the reason why I do that is I just want to ensure that basically that we have kind of the correct amount of
occupant load
stuff that we have in there. So we have people loads, and it's saying that it's 54,824. Now I'm going to come over to the engineer checking. Remember I said about knowing the number of people, and it says that there's 122 people in there. So I would take that and divide it, which equates to about 450 BTUs. And if you look at some of the tables, this I believe comes out of the standard. This is an office. So if you take the where I'm at, moderate work here, 250 and 200, that equates to 450. So these numbers are Okay, this is only if you wanted to get really, really detailed, but what I would do is check the number of people. If it said the number of people that are going to be here is 122, and then when you do your occupant load, it's 13, obviously we have a little bit of a conundrum going on here, and we probably need to get that addressed. All right, so now let's take a look at the carrier HAP report here, and where the train trace is a little bit more of a one-page document. The carrier HAP really has the information kind of on two parts. It has this nice little, what I would call table of information, and then it has like, this is our basic information that kind of translate into it. So if we take a look at this part of it, what it gives us is how many zones do we have within that system. This one happens to have one. Then it lets me know how large of a building is it, right? How many square feet is it? This one is 17,700. And obviously I'm going to take that, look at the plans. If the plans say it is 700 square feet, then either we have the wrong report or they inadvertently put the wrong values somewhere, right? And then I'm going to make sure that it has the correct location. And the reason why I want to make sure it has the correct location, because if this is a project that's in Denver, it's going to be at that 5280 elevation. If it was supposed to be in San Diego, California, there's no elevation there. That's, basically sea level, right? So that really plays into the elevation component of the heating and cooling. Now, this one too is verifying when it's actually going to be occupied. So is this a 24-hour, 365, well, it doesn't have to be 24 hours, but 365 days a year that it's going to be occupied, then it should say January to December. But if this is a seasonal building where it's only going to be in operation like from May to September, then those are the months that it should be shown here. All right. The next one is taking a look at this box right here, and it does correlate. They will correlate with the information here that will translate also into this report. So if we look, it again tells us what our peak loads are. It says, hey, it's in July, it's at 1700 hours. So that means at 5 p.m., the peak loads in July is what they're designing to, because that's the peak loads. And then it gives us the information about our outdoor dry bulb and our wet bulb. So in this instance, where we saw on the train trace, it was a rounded number. In this particular instance, it does have a degree, but what it should show is, again, what is your your jurisdictional adopted temperatures. And that should be what you see listed here. Now, let's take a look at our heating. Now, for our heating, whoops, it didn't quite make it over, but it should be a box right here. For our heating, it says, okay, in this particular instance, it's a -3 for our outdoor temperature, and then our wet bulb is a -4.6. So we just have to, again, ensure that whatever's listed here is what we have adopted. Now, if we come back and we just look at this system as a whole, and this again is dealing with the thermal envelope again. And, I don't know what 141,069 BTUs for my window and skylight loads look like. But what I do have is, here's an example of demonstrating to me what values were actually put into the software. So you'll notice here's a wall detail. It says inside surface resistance, that's paint, right? So we got our paint, our 5/8 chipboard. It says that we have an R14 batt insulation with an R10 spray foam. It also talks about an airspace, and then it has 6 inches of stone and your outside surface resistance, which is, again, paint, right? Now, the thing to kind of be aware of is this airspace, right? It's giving almost an R1 value to that airspace. That means that we need to ensure that that airspace is also included into the uh, wall assemblies when we're looking on the plan. So whatever we see here should also translate to what we see on the plans. Now, here's an example of what we get for our doors. Here is giving us what the U factor is for our glazing, whether it's a door, a window, it's giving us the size and what our U factor is. Now, it doesn't give us the solar heat gain coefficient, but it at least is a step in the right direction. Now, the number of zones, again, looking at all of this, right, we just want to ensure that we are getting the overhead lighting and what our number of zones are, because we can do the same type of calculations that we've done with the other one. Now I'm going to speed up a little bit because I know we're running out of time here. But let's talk about what these loads actually look like. So you'll notice here is the numbers down here. Here is what it is. This is giving us what our total cooling load is, and this is what our total heating load is going to be. Now, these heating loads that we see right here, right? This was our heating load. We should be able to verify that whatever heating equipment we have closely matches what's here. And the same can be said when we're talking about the cooling loads. So here is an example. Here is the report. Here is the information that we have for our heating and cooling. Now, good to see you, Dan. The one thing I will say is remember when you are looking at the loads, especially here, because it's specifically called out, for our heating, you're not looking at the input loads, right? This one says that you need to have 538,877. You need to verify the output. So for the total of this, if it were to equate to the numbers, now for our heating, if we added all this up, which I can't do really quickly, but I can tell you that you are over your heating loads for what is shown here. So all of the output equipment does exceed what this number is. And one of the things that in the energy code does say is obviously we aren't going to have a single piece of equipment that is 538,877, right? So what it talks about is get the next size so that we're as close to it as possible. So there may be times in this, document, this is the total number, but if you start breaking it up by zones, right, which is what these are doing, maybe the output, the zone needed to be 125,000, and this one is showing 128. That's comparable. That works in all of this. Oh, I guess I better be quicker. Okay. So be aware, right? These are the things when we talk about for heating and cooling load calculation, things to review out of it. It's going to look cumbersome because you're going to get a 100-page document. And really there's like 2 sheets that you need to focus on for that. Don't forget, we've got the technical documents located here on the website that will give you all of the technical documents that are up and coming. And so here is some of the webinars that we will have. And I look forward to seeing you all next week. Don't forget to fill out the survey. You guys are awesome. That's why we get to continue this stuff, because you guys fill out the survey. So with that, I'm going to say somehow I made it within time. And I'm going to say thank you all. And I hope you all have a wonderful Thursday. Bye now.
Thank you, everybody.